Okay, very good morning to all. Today we will be discussing session 1 of unit 2, that is a transistor biasing. Let's move to the syllabus. So first, in this chapter, the main content we'll be learning is a transistor as a switch. Okay, then we'll learn how we can use the transistor as an amplifier. Then we'll understand what is the need for biasing, what is mean by biasing. Okay, how we can um, build the biasing circuit, and then we'll discuss about the operating point. So these are the points we'll be discussing in the today's session, and at the last we'll be discussing the multiple choice questions on these topics. Then let's deal with the basics of transistor. So before going to the transistor operation, we must have some basic knowledge. Okay. So coming to the basic of a transistor, we already know that transistor is of three regions. Okay. So one is a emitter region, one more is a base region, one more is a collector region. So it has a three regions. And in transistor, we know that we have two types. One is a NPN, one more is a PNP. In a NPN, the emitter region will be having the N material, and the base will be having the P material, and collector will be having the N. So it's called as NPN. Okay, this is commonly used transistor. And also we have one more kind of a transistor is called PNP, where emitter will be having the P type, and base will be having the N type, and collector will be having the P type. So that will be a PNP transistor. Okay, this is the basic structure of the transistor. And remember, this will be taken as an input circuitry. Okay, emitter base uh, junction or the portion, and the base collector will be taken in the output circuitry normally. Okay, we can have a different with the different configurations. Next, these are the symbols of NPN and PNP. You can see here we have a three terminals: emitter, base, and collector. And emitter will be indicated by the arrow mark. So arrow mark indicates the emitter of a transistor. Even in this diagram, you can see we have a arrow mark that indicates the emitter, and to indicate whether it's a PNP or NPN, we have a arrow mark direction. If the arrow mark direction is towards the base, it indicates it's a PNP. If the arrow mark direction is away from the base, it indicates the NPN. Okay, so this is the basic of transistor symbols. Then we have three different configurations how we can use the transistor. One is a common base. You can see here it is the input, and this is the output circuitry. This base is common to the input as well as output. So it is called as a common base configuration. Okay. So you can see here the emitter is shown with the arrow mark with the moving away from the base. So it indicates it's a NPN transistor. Then this is the CE configuration. In a CE configuration, CE means common emitter. You can see this emitter is common between the input and the output. Okay. Similarly, for the CC configuration, CC means common collector configuration. Collector will be common between the input and output. So these are the different configurations we can achieve using the transistor. And here you can see we have a DC supply. Okay. So we will deal about this DC and AC in the next slide. So coming to the operating modes of a transistor, we have a different operating modes. Even you already learned it in the previous semester. That is active mode, and cutoff mode, and saturation mode. These are the three modes of operation of a transistor. Active mode. Active mode means whenever we want a transistor to use as a amplifier. So amplifier means the one which increases the strength of a signal. Okay. So when we want to transistor use as an amplifier, we must use it in a active mode. How we can use the transistor in active mode? By keeping emitter base junction. Remember the structure, emitter base collector. So emitter base junction, when it is forward biased, and collector base junction is reverse biased, then it is called as a active mode. Understood this? So, so coming to the one more type, if I want to use the transistor as a switch, okay. So switch means it should turn on and turn off, or close and open the connection. Okay. So we have one more called cutoff mode. In this mode, we can use the transistor as an open switch. So what is meant by open switch? The switch which does not allow any current to flow. That is the meaning of open switch. We can use the transistor as an open switch by keeping it in the, or using it in cutoff mode. How we can use the transistor in cutoff mode? By keeping the both collector base junction and emitter base junction in a reverse biased. We already know forward bias and reverse bias. Okay. So when positive terminal of the supply is given to the P type, it is called and negative is connected to the N type. then it become a forward bias. If it is reverse, it will be a reverse bias. Okay. So by connecting like this, we can achieve the transistor as a open switch. Similarly, we have one more mode called saturation mode. In this, we can use the transistor as a on switch or a closed switch. So in this mode, we have to keep emitter base and collector base junction both are in a forward bias. Okay. If we keep both in reverse bias, then it become a cutoff mode and acts as a open switch. If you keep both in a forward bias, then it acts as a closed switch, that is called as a saturation mode. So these are the three modes of operation of a transistor. Now tell me, if I want to use the transistor as an amplifier, which mode I have to use? So I have to use as in a active mode. So how I can use the transistor in active mode? I have to keep the emitter base in a forward bias and base collector in a reverse bias. Okay, base collector should be reverse bias. You must remember this concept. And if I want to use the transistor in a switch, I have to use it in these two modes, cutoff mode and saturation mode. Whenever I keep uh, emitter base and base collector in a reverse bias, then it acts as a cutoff mode, means it's open switch. When I keep both in a forward bias, then it acts as a closed switch. We call it as a saturation mode. Okay, so these are the three modes of a transistor. I hope you understood these concepts. Okay, because based on this only we will understand how we can use the transistor as a switch or transistor as a amplifier. Next we will see the operating regions of a transistor. So this diagram shows the different regions. So normally whenever we want a full current or high current, we keep the transistor in a saturation region, because we know that saturation region means it is fully on. Whenever the switch is fully on, what happens? It passes the maximum current. Okay, so then if I want no current to pass, I want to block all the current, or I don't want any current to pass, then I can use the transistor in the cutoff mode. We can call it as a fully off. Just you can remember or recall like a open switch. Whenever the switch is completely open, then no current will flow. Okay, so that type you can use. So coming to this diagram, you can see at this mode the output voltage is almost near to zero, but the current will be maximum. Okay, you can obtain the maximum current at this point. This point is called as a saturation region, and we can obtain this by calculating this. Okay, we'll go through this how we will getting this equation. IC is equal to VCC by RL. VCC andre supply voltage, RL andre load resistance, and normally the VCE means output voltage, emitter collector voltage, that will be kept constant zero. Then we'll be taking this point. Okay, e point name kartino saturation region point at karti. Normally these hashed line, what you can observe here, this is a saturation region where you can get the maximum current and the transistor will be fully on. And here we have one more region. Whenever I keep the IC current zero, this happens when I keep the transistor in the cutoff mode, because we know that in a cutoff mode it will be reverse bias and it is not allowing any current to pass. Okay, that time what will be the current? IC will be zero only. IC means it's a collector current, it will be zero. Then only the voltage will be flowing at the output. Then VCE means collector emitter voltage will be equal to your supply voltage. So this point is called as a cutoff region. So normally this hashed line, what you can observe here, this is a cutoff region. The transistor will be fully off. So these are the two regions what we can use to operate the transistor as a switch. And here you can see the one more region. This is very important reason, because if we want to use a transistor as an amplifier, we must use a transistor in this region. Okay, this region is called an active region. We know that when the transistor will be active region, when we keep the emitter base in a forward bias, base collector in a reverse bias, then we'll get this region. Okay, and this point, it's called as a Q point or operating point. So operating point means whenever there is no any input signal is applied. Okay, then what is the operating level of your transistor? Okay, so that is what is the operating point. We'll deal about it in the next slide. Okay, so this is the operating regions of a transistor. This is the saturation region, fully on, maximum current will be flowing. This is the cutoff region where the zero current or very minimal current will be flowing. Okay, and this is the active region where the transistor will be acting as an amplifier. Okay, so these are the main three regions of a transistor. Understood this? Understood this one? Okay, So if you already understood the previous concept, this one we can easily understand because we already discussed how we can use the transistor as a switch. So how I can use the transistor as a switch, what I have to do? Hmm? So I can use the transistor as a switch just by operating the transistor in the two modes. What are those two modes? Cutoff mode and the saturation mode. Whenever I operate the transistor in the cutoff mode, it acts as a open switch. Whenever I use it in the saturation mode, it acts as a closed switch. Okay. So this is a simple one. How I can use the transistor as a switch. Let's go through this. A transistor is used as a switch for opening or closing of a circuit in the electronic device. Transistor acts as a switch when it is operated in a saturation region and cutoff region. Saturation means it will be a fully on condition. Cutoff means it's a fully off condition. Okay. So you might have already seen this kind of a switches, normal switches, where we can operate on and off. Okay, it may be on in a lab to on and off your devices like power supplies, function generator, or any other devices, or even at home you might have seen this kind of a switches. But in our electronic circuit, every time we cannot use this kind of a switch because these switches has to be operated manually. Okay, in our electronic circuits, we need a switch which can be operated by electronically only. So example, you can take in a home, we'll use many electronic lightings, correct? So lighting ಎಲ್ಲ ನೋಡಿರ್ತೀರಿ ಮನೆಯಲ್ಲಿ usually in a Ganesh Chaturthi, Deepavali, we use a lighting and all. In that time, if you want to operate it automatically, on and off ಆಗುತ್ತೆ, you might have seen it. If you want to use it like that, then we will be using the transistor as a switch. Okay, so these are the manual switches, and the transistor will be using as a electronic switch. Okay, so coming to the saturation region, we already know switches will be acting like a on. So here we will understand with the circuitry. We already understood the theoretical part. Here we will be going with the circuitry. So this is a common emitter configuration. You can see here the input is applied to the base and the load is RL. Okay. So whenever the input is applied, and remember one thing, in a transistor, will be for when we are operating the transistor, we may have two voltages. One is AC, one more is a DC. So AC is nothing but the input signal, which signal you want to operate. Okay, especially when you are using it in the amplifier. If you want to amplify the signal, then you will be using the input signals. Okay, information signal that will be in the form of AC. When you to operate the transistor, you will be using the DC. Okay, so here you can see I'm providing the signal, base signal. So it has the input. Input voltage ಯಾವ್ದಾಗುತ್ತೆ ನೋಡ್ರಿ ಇದರಲ್ಲಿ ಬೇಸ್ ವೋಲ್ಟೇಜ್ ಇಸ್ ಅಪ್ಲೈಡ್. ಇಟ್ ಈಸ್ ಬಿಟ್ವೀನ್ ದ ಬೇಸ್ ಅಂಡ್ ಎಮಿಟರ್. ಈ ವೋಲ್ಟೇಜ್ ನಾವು ಏನು ಕರಿತೀವಿ VBE ಅಂತ ಕರಿತೀವಿ. ಯಾಕಂದ್ರೆ ಇನ್ ಫ್ಯೂಚರ್ ವಿಲ್ ಬಿ ಯೂಸಿಂಗ್ ದ ಟರ್ಮ್ಸ್ ಲೈಕ್ VBE voltage. What is mean VBE? Voltage between the base and emitter. This only. Okay. And whenever the input voltage is applied, then it become a forward bias. Correct. We know that whenever the input voltage is applied to the transistor, okay, more than the 0 volt, it acts as like a closed switch. You can see here the red line what you are observing here, it indicates that the transistor is acting like a closed switch. So now you observe, whenever it is closed, the voltage, the current will flow to the ground or it will go to the output. So what will be the output? See here, this output what will be getting, it is connected to the ground. So output voltage will be what? Output voltage will be 0. Okay, understanding this, you can observe here the voltage is given here, the VCC flows like this. Okay, the current what it is flowing through this, you can calculate like IC is equal to VCC by RL. That is the current. Okay, this current is flowing like this. Whenever this is open switch, this voltage will goes to the Vout because this path is open. But in this case, in saturation region, this is closed, right? So when this is closed, the voltage will goes to the ground and the output is connected to the ground only. So you can see here the output is connected to the ground through this closed switch. So what will be the output at this time? It will be 0 because it's connected to the ground, right? Then the current IC here, how you can calculate the IC? The current flowing through this collector, it will be VCC by RL, because we know that I equal to V by R as per our Ohm's law. The voltage flowing here is VCC and the resistance here is RL. So current through the collector or IC is equal to VCC by RL. So this is the saturation region. Okay, let's go with this. Its characteristics. The input and base are connected to the VCC. This one base emitter voltage is VB is more than 0.7 volt. This one. So since it is more than 0.7 volt, it is acting as a closed switch. The base emitter junction is forward bias and the collector base junction is also forward bias. Since both are in forward bias, it is acting like a saturation region. Maximum collector current flows IC is equal to VCC by RL. I told you here IC will be the current flowing through the load. It is a V by R. V is a VCC. R is a RL. So this is the maximum collector current flowing through the load. And the VCE, this output voltage, you can see here, since it is shorted, what will be the voltage present here? It will be 0. Okay, because it's a short. So VCE, since it is short, it become a 0. And the V out also 0 because it's a V out equal to VCE. So whatever the voltage is there between the collector emitter, that will be taken as output. Since this is shorted, the VC is 0. That means V out is also 0. So this is called transistor is operating in a closed switch. So closed switch agide. So it acting like a closed switch. This is the switch is on. So understood how we can use the transistor as a closed switch. Okay. Similarly, we can see how we can use the transistor in a open switch. So we can operate the transistor in a cutoff mode state or cutoff mode region. Then I can use it as a open switch. In a cutoff state, emitter based junction and collector based junctions are reverse biased. Okay, you can see this here. The base and emitter are connected to the ground. When this input is grounded 0, then will it be in a forward bias? No, it will not turn on, and it acts like a open switch. It's a representation of this condition. Input is grounded. Since it is grounded, there is no any signal or DC supply is given to the base emitter, and we know that minimum voltage required to turn on this is a more than 0.7 volt. If it is less than 0.7 volt, it will not turn on. It acts like a open switch. Okay, so here it is acting like an open switch. Now you understand the voltage is not flowing to the ground because it's an open switch. Whatever the voltage coming here, it goes to the output only, right? So output, this entire voltage flows to the output. Since this path is closed, there is no any collector current. Okay, collector current will be 0. Collector ಯಾವ current pass ಆಗುತ್ತೆ ಇದರಿಂದ ಇಲ್ಲಿಂದ current conduction ಆದ್ರೆ ಮಾತ್ರ collector ಅಲ್ಲಿ current ಇರುತ್ತೆ. Otherwise the collector current will be 0. So let's go with its characteristic. The input and base are grounded, so it is nothing but a 0 volt. The base emitter voltage is less than 0.7, so it is a reverse bias. The base emitter junction is reverse bias, and base collector is also a reverse bias. Transistor is fully off, so it's act like a off switch. No collector current flows because it is okay. Are you able to hear my voice now? Okay. So since this is an open switch, the collector current is absent because there is no current flowing through the transistor. The collector current will be 0 because this transistor itself are off. Then there is no chance of the collector current existence. So collector current IC will be 0. The output, how it will be taking the output? The voltage flowing through the VCC. The VCC will be taken as 1, means highest voltage that will be flowing to the output. So V out is equal to VC equal to 1. And the transistor operated as a open switch. So this is how you can use a transistor as a off switch or a open switch. Okay. So this is a one more reason. Now we will understand how I can use the transistor as an amplifier. So this is a circuit of an amplifier. So here you can see I am using the transistor in the common emitter configuration. So emitter is common between the input and output. Remember one thing. So if I want to use it in the amplifier, which region I have to use it? So I have to use the transistor in an active mode. How I can use the transistor in active mode? I have to keep this emitter base in a forward bias, and this other portion base collector base junction should be a reverse bias. How I can achieve that? How I can make a forward bias and reverse bias? By applying the DC supply. Just forget about this. This is the signal. Just remember these two things are applied. This is the DC. So why I am using the DC? I want to keep the transistor base emitter in a forward bias and a base collector in a reverse bias, so that the transistor will be operating in an active region. For that I am using the DC. Okay. So these DC will set the operating point. Operating point means how the transistor can operate. So that operating point will be set by the DC without any input signal. Okay, so input signal ಅಲ್ಲಿ ಏನು role play ಮಾಡೋದಿಲ್ಲ. We are using only DC to set the transistor. Once the complete transistor is set to operate as amplifier, then we apply the signal. ಆ signal normally ಏನಾಗಿರುತ್ತೆ AC form ಅಲ್ಲಿ ಇರುತ್ತೆ. Okay, remember what are the signals we have? We have a AC as well as a DC. DC used to set the transistor, okay, to operate in a particular region, and AC is a input signal. So understood this? Since we have made it is a forward bias and this is a reverse bias, it acting like a, it is operating in active region. So now we will go through the operation. So this is the input signal what I am applying to the input, and this is the output signal what I am receiving from the transistor. Let's see. So now we are applying the base voltage. So that is on. So ಇದನ್ನ forward bias ಮಾಡಿದೀನಿ. Forward bias ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ಇದು transistor acting like a closed switch and it is operating. It's ready to conduct. Whenever there and collector current also flowing. Okay. So whenever the positive signal is applied, ಈ positive ಕೊಟ್ಟಾಗ ಏನಾಯ್ತು it's already on. Whenever there is some positive signal is applied, this collector current start flowing. Collector current flow ಆಗಿ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಕರೆಕ್ಟ್. ಸೊ ಇಲ್ಲಿ ನಾವು ಮ್ಯಾಕ್ಸಿಮಮ್ ವೋಲ್ಟೇಜ್ ಅಪ್ಲೈ ಮಾಡಿರ್ತೀವಿ. ಸೊ ಏನಾಗುತ್ತೆ, ಸೊ ಕಲೆಕ್ಟರ್ ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜ್ ವಿಲ್ ಬಿ ಸ್ಟಿಲ್ ಮೋರ್ ಇನ್ಕ್ರೀಸ್. ವಿ ಈಕ್ವಲ್ ಟು ಐ ಇಂಟು ಆರ್. ನೆನಪಿದೆ ನಿಮಗೆ? ಸೊ ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಐ ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ. ಸಿನ್ಸ್ ದ ಬೇಸ್ ಕರೆಂಟ್ ಇನ್ಕ್ರೀಸ್, ದ ಕಲೆಕ್ಟರ್ ಕರೆಂಟ್ ಆಲ್ಸೋ increases, because we know that as the base current increases it acts like a closed switch and it will allow the current to flow. So automatically ಏನಾಗುತ್ತೆ, collector current to flow ಆಗಕ್ಕೆ ಶುರು ಆಗುತ್ತೆ. So higher current will start flowing. The output voltage V equal to I into R. So I ಏನಿದೆ ಇದಿದೆ, ನೀವು higher load resistance ಹಾಕಿರ್ತೀರಿ. So I into R ಏನಾಗ್ಬಿಡುತ್ತೆ, ಅದು you will be getting the output higher voltage. So this is the during the forward bias. Let's say during the negative bias, negative half cycle. During the negative half cycle, it is having the negative highest negative voltage. In that condition, what happens? The collector current will also increase. Okay, since the base current also increasing negative, the collector current also increases, but in the negative way. So this is how you will get the maximum reverse output voltage. Means it's a negative voltage you will be getting at the output of the amplifier. So whenever you are getting the input signal, that will be amplified. The main reason is the transistor will be controlled by the base current. Whenever it is positive, the current start flowing in a positive direction. The output will be with a higher current, with a higher voltage. So output will be more higher. During the negative half cycle, it will be having the negative. Then also current start flowing in a reverse direction in the negative. So you can observe the higher negative voltage. So this is how this will start amplifying the signal. Okay. So this is a transistor operating as an amplifier. Okay. Let's go with some statements. Transistor acts as an amplifier by raising the strength of a V signal. So it is used to amplify the weak signal, or you can say it can boost the signal strength, okay, or it can increase the signal strength. The battery VBB is connected to the input circuit in addition to the signal voltage. So this is in addition to this. Okay, this is the information signal what you want to amplify, but this VBB is nothing but it is a voltage given to set the transistor in an on condition. Okay, so remember that this DC voltage what you are applying to turn on the transistor is called as a bias voltage. If you are using any circuit to set the voltage, that will be called as a biasing circuit, because you will be learning that in the next session. That is a bias circuit. It may be voltage divider circuit and other circuits. Okay, so voltage providing to bias the transistor is called a bias voltage, and its magnitude is such that it always keeps the emitter base junction forward bias regardless of the polarity of the signal source. It means even though it is negative, the input signal what you are applying is negative, but the transistor is not off because it's already made the switch transistor to operate in a on mode. Suppose just assume that there is no VBB is applied. Then what happens? Whenever the input signal is above 0.7 volt, then it will turn on. Whenever it is less than 0.7 volt, it will turn on. But now that is not the case, because you applied the separate DC signal, okay, just to turn on the transistor. That means your transistor will be continuously on irrespective of your input signal. Okay, so this is about the transistor as an amplifier. So let's read the operation of this. When the signal voltage is applied, the forward bias on the emitter base junction increases because it is already forward bias because of the DC signal. That will increase by applying the signal. or it may decrease because it depends upon the polarity of the input signal, depending upon whether it's the positive or negative. During the positive half cycle of the signal, the forward bias on emitter base junction is increased, causing the total current IC to increase. Reverse will happen for the negative half cycle of the signal. That means input signal is positive, the output will be having the more collector current. If the input signal is negative, it will be having the more collector current in the negative direction. Okay, so this is the operation of a transistor as an amplifier. And one more thing, whenever there is no signal, then you cannot assume that the transistor is off or the circuit is off, because we have supplied the VBB which keeping your transistor on. So you can expect some DC collector current. Okay, that DC collector current IC will be written like this, capital IC. It indicates a DC current flows in the collector circuit. This current is called zero signal collector current. It is because there is no signal at the input side. Input ಅಲ್ಲಿ ಏನು signal ಕೊಟ್ಟಿಲ್ಲ, even then you are getting some output current. It is because of what? The base DC signal what you have applied. So ಅದನ್ನ ನಾವು ಏನು ಕರಿತೀರಿ? Zero signal collector current ಅಂತ ಕರಿತೀರಿ. Okay, when you are given some AC signal, then you also will have some collector current. ಅದನ್ನ ನೀವು small IC ಇಂದ indicate ಮಾಡ್ತೀರಿ. That is the AC collector current. So total output current will be small I capital C. It indicates that it has both AC and DC. Small IC indicates the AC signal, capital IC indicates the DC signal. So that will be present in the output of the amplifier. So now, so we'll understand what is meant by operating point. So we already understood that the transistor will be operating in the three regions: saturation region, cutoff region, and active region. So now we have to set the points. So before you using your input signal, AC signal, you will be setting your transistor to operate, correct? So ನೀವು DC signal ಕೊಟ್ಟು ಏನು ಮಾಡ್ತೀರಾ, ಅದನ್ನ ಆಪರೇಟ್ ಮಾಡಲಿಕ್ಕೆ ರೆಡಿ ಮಾಡಿರ್ತೀರಿ. ಅದನ್ನ ನಾವು ಏನು ಕರಿತೀವಿ? ಆಪರೇಟಿಂಗ್ ಪಾಯಿಂಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಒಂದು ಕಲೆಕ್ಟರ್ ಕರೆಂಟ್ ಪಾಯಿಂಟ್ ನ ಸೆಟ್ ಮಾಡ್ತೀವಿ, ಇನ್ನೊಂದು ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜ್ ನ ಸೆಟ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, so let's go with this. The point which is obtained from the values of the collector current IC and the collector emitter voltage VCE when no signal is given to the input is known as the operating point. So understand it clearly. This is obtained from the collector current and collector emitter voltage. Recall your circuitry. Output alliro current ಯಾವುದು? Collector current. Output alliro voltage ಯಾವುದು? Collector emitter voltage. ಆ voltage ಅನ್ನು ತಗೊಳ್ಳೋದು, that too when there is no signal is applied. Input ಅಲ್ಲಿ ಯಾವುದೇ signal ನೀವು ಅಪ್ಲೈ ಮಾಡಿದಿಲ್ಲ, ಅವಾಗ ನೀವು ತಗೋತಾ ಇದ್ದೀರಿ, ಅದನ್ನ ನೀವು ಆಪರೇಟಿಂಗ್ ಪಾಯಿಂಟ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀರಿ. ಯಾವ ಪಾಯಿಂಟ್ ಅದು? IC collector current and VCE output voltage. It is called operating point because variations of IC and VCE takes place around this point. ಅಂದ್ರೆ ಸಿಗ್ನಲ್ ಏನಿದೆಯಲ್ಲ ಅದರ ಸುತ್ತಮುತ್ತನೇ ಚೇಂಜ್ ಆಗ್ತಾ ಇರುತ್ತೆ when no signal is applied to the input. So understood this operating point. So ನೀವು ಒಂದು ಆಪರೇಟಿಂಗ್ ಪಾಯಿಂಟ್ ನ ಸೆಟ್ ಮಾಡಿ ಇಡ್ತೀರಿ. ಅದು ಯಾವಾಗ? ಸಿಗ್ನಲ್ ನೀವು ಅಪ್ಲೈ ಮಾಡೋಕ್ಕಿಂತ ಬಿಫೋರ್. ದಟ್ ಮೀನ್ಸ್ ವಾಟ್? ಯು ಆರ್ ಕೀಪಿಂಗ್ ಯುವರ್ ಟ್ರಾನ್ಸಿಸ್ಟರ್ ರೆಡಿ ಟು ಆಪರೇಟ್. ಓಕೆ, ಸೊ ಇದು DC ಸಿಗ್ನಲ್ ಇಂದ ಸೆಟ್ ಮಾಡಿ ಇಡ್ತೀರಿ. So this is the waveform you can see. So this is the collector current and this is a collector current. I can take the collector current by VCC by RC. I told you RC means it's a collector resistance, or you can take it as a RL. So that I can calculate the IC by VCC by RC or RL, and here VC nothing but VCC. Okay, so now these are the 2 points. I can get this IC by keeping the voltage 0. Okay, that is normally in a saturation mode. Saturation mode ittaga enagutte nimage collector current barutte, voltage output voltage is 0 error. So then you can calculate the IC by VCC by RL. Similarly, I can get the VCC point or VCE point. Okay, so or the output voltage by keeping the transistor in a cutoff mode. Cutoff mode ittaga enagutte collector current is 0 agutte, you can get the maximum output voltage. Okay, maximum output voltage what you can obtain is a VCC. So these are the 2 operating points. So ಈ ಎರಡು ಆಪರೇಟಿಂಗ್ ಪಾಯಿಂಟ್ ಲಿಂದ ಏನು ಮಾಡ್ತೀವಿ, ನಾವು ಒಂದು ಲೈನ್ ನ ಡ್ರಾ ಮಾಡ್ತೀವಿ. ಈ ಲೈನ್ ನಾವು ಏನು ಕರಿತೀವಿ? ಲೋಡ್ ಲೈನ್ ಅಂತ ಕರಿತೀವಿ ನಾವು. ಸೊ ಇದೆಲ್ಲ ಆಗೋದು ಯಾವಾಗ? ವೆನ್ ದೇರ್ ಇಸ್ ನೋ ಸಿಗ್ನಲ್ ಇಸ್ ಅಪ್ಲೈಡ್. ಇನ್ನು ಸಿಗ್ನಲ್ ಏನು ಅಪ್ಲೈ ಮಾಡಿಲ್ಲ, ನೀವು ಜಸ್ಟ್ DC ಕೊಟ್ಟಿದ್ದೀರಿ, ನಿಮ್ಮ ಟ್ರಾನ್ಸಿಸ್ಟರ್ ಈ ತರ ಬಯಾಸ್ ಆಗಿ ರೆಡಿ ಆಗಿದೆ. ಸೊ ದೀಸ್ ಆರ್ ದ 2 ಪಾಯಿಂಟ್ಸ್ ಕಾಲ್ಡ್ ದ ಆಪರೇಟಿಂಗ್ ಪಾಯಿಂಟ್. ದ ಲೈನ್ ಜಾಯಿನಿಂಗ್ these 2 lines, these 2 points is called a DC load line. And so base will be given with some current to operate, that is taken as a IB, base current IB. ಇದು ಎಲ್ಲಿ ಬಂದು ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗುತ್ತಲ್ಲ ಇದನ್ನ ನಾವು ಆಪರೇಟಿಂಗ್ ಪಾಯಿಂಟ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, so the intersection of the load line and your base current, this is called the operating point. Okay, so I hope you understood this structure. So next, see what is meant by biasing. So biasing means what? So setting the DC operating voltage. I already told you. So we will be supplying the biasing voltage, or we will be setting the transistor in the forward bias and reverse bias as per our need. So biasing means it is the process of setting a transistor DC operating voltage or a current condition to the correct level so that any AC input signal can be amplified correctly by the transistor and it operates in a linear active region. This is done by using the external components such as resistor and capacitor and applying the DC voltages to the transistor. It means what? So before applying the input signal, you will be keeping your transistor ready for the operation. ಸೊ ಯಾವಾಗ ನೀವು ಟ್ರಾನ್ಸಿಸ್ಟರ್ ರೆಡಿ ಮಾಡಿಟ್ಟಿರ್ತೀರೋ ಬೈ ಸಪ್ಲೈಯಿಂಗ್ ದ ಡಿ ಸಿ ಸಿಗ್ನಲ್, ಯಾವಾಗ ಸ್ವಲ್ಪ ಸಿಗ್ನಲ್ ನೀವು ಇನ್ಪುಟ್ ಕೊಟ್ಬಿಟ್ರು ಇನ್ಪುಟ್ ಅದು ಆಂಪ್ಲಿಫೈ ನಿಮ್ಮ ಔಟ್ಪುಟ್ ಹತ್ರ ಬರುತ್ತೆ. ಓಕೆ, ಇಫ್ ದಿಸ್ ಈಸ್ ನಾಟ್ ಅವೈಲಬಲ್ ದೆನ್ ಆ ಸಿಗ್ನಲ್ ಬಂದಿರೋ ಸಿಗ್ನಲ್ ಅದು ಪ್ರಾಪರ್ ಆಗಿ ಆಂಪ್ಲಿಫೈ ಮಾಡೋದಿಲ್ಲ. ಓಕೆ, ಸೊ ಬಯಾಸಿಂಗ್ ಅಂದ್ರೆ ಏನಿದನು ಡಿ ಸಿ ಆಪರೇಟಿಂಗ್ ಪಾಯಿಂಟ್ ನ ಸೆಟ್ ಮಾಡಿಡೋದು, ಅದಕ್ಕೆ ನಾವು ಬಯಾಸಿಂಗ್ ಅಂತ ಕರಿತೀವಿ. ದ ವೋಲ್ಟೇಜ್ ವಾಟ್ ಐ ಆಮ್ ಅಪ್ಲೈಯಿಂಗ್ ದಟ್ ಇಸ್ ಬಿ ಕಾಲ್ಡ್ ಆಸ್ ಅ ಬಯಾಸಿಂಗ್ ವೋಲ್ಟೇಜ್. ಓಕೆ, ಆ ಬಯಾಸಿಂಗ್ ವೋಲ್ಟೇಜ್ ರೆಡಿ ಏನ್ ಮಾಡುತ್ತಲ್ಲ ಸರ್ಕ್ಯೂಟ್ರಿ, ಅದನ್ನ ನಾವೇನ್ ಕರಿತೀವಿ ಬಯಾಸಿಂಗ್ ಸರ್ಕ್ಯೂಟ್ ಅಂತ ಕರಿತೀವಿ ನಾವು. ಓಕೆ, so biasing circuit is the one which is generating the biasing voltage. Understood? So remember biasing voltage must be more than 0.7 volt. So 0.7 volt ಗಿಂತ ಹೆಚ್ಚಿಗೆ ಇತ್ತಂದ್ರೆ ಏನಾಗುತ್ತೆ ನಿಮ್ಮ ಟ್ರಾನ್ಸಿಸ್ಟರ್ ಟರ್ನ್ ಆನ್ ಆಗಿ ಇರುತ್ತೆ, so that whenever the signal is applied it will amplify. Okay, so what is the need for biasing? So biasing ಕೊಡಲಿಲ್ಲ ಅಂದ್ರೆ ಏನಾಗ್ತಾ ಇತ್ತು, ಒಂದು ಪ್ರಾಪರ್ ಫ್ಲೋ ಆಫ್ ಜೀರೋ ಸಿಗ್ನಲ್ ಕಲೆಕ್ಟರ್ ಕರೆಂಟ್. ಸೊ ನೀವು ಏನು ಸಿಗ್ನಲ್ ಇಲ್ಲ ಅಂದಾಗ ನಿಮ್ಗೆ ಔಟ್ಪುಟ್ ಅಲ್ಲಿ ಜೀರೋ ಇರುತ್ತೆ, ಯಾವಾಗ ಸಿಗ್ನಲ್ ಕೊಡ್ತಿರೋ ಅವಾಗ ಸಿಗ್ನಲ್ ಆಂಪ್ಲಿಫೈ ಆಗಿ ಬರುತ್ತೆ. Okay, and maintenance of the proper collector emitter voltage means output voltage. ನೀವು bias cut ಮಾಡಿಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ output voltage ಕರೆಕ್ಟ್ ಆಗಿ ಬರುತ್ತೆ. Whatever the input you have given, it will be amplified properly and it will be available at the output side. ಆಮೇಲೆ ಇನ್ನೊಂದು ಏನಿದೆ ಅಂದ್ರೆ we can keep the transistor in the active region. How it's possible? By using the biasing. So biasing ಅಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ ನೀವು emitter base junction forward ಮಾಡ್ತೀರಿ, collector base junction reverse ಮಾಡ್ತೀರಿ. By doing this, the transistor will be operating in the active region and it can be operating as a amplifier and it stabilizes the operating point. So just previous of this slide I told you about the operating point, it stabilizes. Okay, so we will learn about the stability in the next class. Stability means ಅಂದ್ರೆ ಏನು operating point vary ಆಗಬಾರ್ದಪ್ಪ ನಿಮ್ಗೆ, so that can be stabilized using the this biasing. So I hope at least you understood this concepts today. Okay, once again we will go through the multiple choice questions. So when a transistor is operated as a switch, it works in the following regions. So active and cutoff, cutoff and saturation, active and saturation, none of the above. Which one is the correct answer? Okay, so everyone can answer it now. Which one is the correct answer for this? So B is the correct answer. We know that whenever I want to use it in a switch, I have to use it in a cutoff and saturation. Cutoff means it's act like an open switch, saturation means it acts like a closed switch. Okay, so this is the correct answer. Next, a transistor may be used as a switch, rectifier, resistor, tuning device. Which one is correct answer? See, here it is telling the transistor. I can use a switch, yes or no? Yes, we have seen how I can use it as a switch, so it's the correct answer. Rectifier, can I use a transistor as a rectifier? Not possible, correct? Because I can use a diode as a rectifier, but I cannot use the transistor as a rectifier, so it's a wrong answer. So transistor may be used as a resistor. So normally we not use the transistor as a resistor, so this is also wrong answer. So tuning device, this is also wrong answer. So correct answer is option A, switch. Next, coming to the third question, operating point represents. So I already told you operating point by applying the DC signal, which sets the 2 point. One is the collector current, one more is the output voltage. Okay, let's go with the options. Values of IC and VC means output current and output voltage when signal is applied. This one option. The magnitude of the signal, zero signal values of IC and VC, none of the above. Which one is the correct answer? Okay, so many times you may get confusion between the option A and C. Option A says that value of output current and output voltage when signal is applied. Signal means that it's an input signal, information signal, and the C says that zero signal values of IC and VC. Zero signal means zero information signal. So remember one thing, operating point is a one which is set by the DC signal, means DC value VBB. So DC voltage ಕೊಟ್ಟು ನೀವು set ಮಾಡಿರ್ತೀರಲ್ಲ ಅದು ನಿಮ್ಮ ಆಪರೇಟಿಂಗ್ ಪಾಯಿಂಟ್ ನ ಸೆಟ್ ಮಾಡುತ್ತೆ. In that time there is no any signal is applied. ಅರ್ಥ ಆಯ್ತಾ? You will be setting the transistor ready for the operation, that is called as operating point. That means there is no any signal is applied. That means the option C will be correct. Okay, I repeatedly told you that there is no signal is applied, so that means the option A is wrong. Okay, so option C is the correct answer. So if you have any doubt, you can go back to the operating point concept what we have discussed today. Then it is clearly mentioned it's a value of IC and VC when there is no signal is applied, means zero signal. Next, move to the next question. Transistor biasing represents dash condition. So biasing ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ತೀರಿ ನೀವು ಅದನ್ನ ಸೆಟ್ ಮಾಡ್ತೀರಿ ಟ್ರಾನ್ಸಿಸ್ಟರ್ ನ, either it may be active region, saturation region, cutoff region. biasing set ಮಾಡೋದು biasing voltage ತಗೊಂಡು. Okay, so ಇದನ್ನ set ಮಾಡಕ್ಕೆ ಏನು ಯೂಸ್ ಮಾಡ್ತೀರಿ? Are you using AC or DC, or using both AC or DC, or none of the above? What you will be using to set the transistor biasing? So we know that biasing means what? Setting the transistor, correct, to making the transistor in a forward bias or reverse bias. That will be done only using the DC, correct. So DC ನ ಅಪ್ಲೈ ಮಾಡಿಬಿಟ್ಟು ನೀವು bias ನ ಸೆಟ್ ಮಾಡ್ತೀರಿ, ಆಮೇಲೆ AC ಸಿಗ್ನಲ್ ನ ಅಪ್ಲೈ ಮಾಡ್ತೀರಿ. So transistor biasing represent the DC condition of the transistor. Okay, so option B is the correct answer. So coming to the fifth question, in a transistor collector current is controlled by. So output collector current ಎದರಲ್ಲಿಂದ ಕಂಟ್ರೋಲ್ ಆಗುತ್ತೆ? How to be controlled? Collector current ಎದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ ಹೇಳ್ರಿ? In the expression base, no. So see the options. Collector voltage ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತಾ? Base current, collector resistance, and all of the above. See here. So in the explanation I told you the switch will be on or off based on the base current. Whenever the base current is present, then the switch acts like a closed switch, then there will be existence of the collector current. Okay, so that means it's completely controlled by the base current. If the base current is zero, collector current will be zero. When the base current is present, the collector current will also present. That indicates that collector current is controlled by base current. So option B is a correct answer. So I hope you understood the today's session. So in the today's session we have discussed how we can use the transistor as a switch. Okay, before that we understood the different regions of a transistor, different modes of operation. Then we understood that how I can use the transistor as a switch and transistor as an amplifier. Okay, and also we understood about the operating point. So I hope you understood all the concept.